Good evening, everyone. Now, my topic is Basic of Image Pattern Classification for the subject Computer Vision. Now, welcome to this presentation on the fundamental of image pattern classification. This is an exciting field that bridges computer science and artificial intelligence to analyze and understand images in a way that mimics human visual process by machinery. Now, introduction to image classification, there two types, core concept and application. Now, core concept, image classification is a fundamental task in computer vision. It involves identifying the category or label associated with an image, or instance classifying an image as a dog, cat, or bird. It simply means based on the image pattern and some small details like dog, cat, and bird. Bird has wings, cat has tail and some feathers, and dog has a tongue licking out. Are these are small categorical values which we assign and we are not systems identify and make difference between these things. Now, applications and image classification plays a crucial role in numerous applications, including medical diagnosis, self-driving car, object detection in surveillance system, and more. Now, key concept and terminologies. Features are distinctive characteristics ex- extracted from images that help distinguish different categories such as color, texture, shape, or edge information. Now, what are the features of in this? The features like categories such as color, texture, and shape, or edges. These small details helps us to identify the images. Now, what are classifiers? Classifiers are the algorithms that learn from labeled data to predict the category of unseen images. They use mathematical models to categorize images based on extracted features, like category mathematical models like CV and CV2. Basically, we use this type of models. There are widely used models and the libraries we use for this. Now, training data. Training data consists of label information that are used to train classifier. This data helps algorithm to learn to associate features with specific categories. Now, what is training data? Before bringing this model to the public, we train this database based on some important and training data information like pictures of cat, dogs, and some other different pictures. We train this data, but the real data is not be seen by this machine, and when this machine gets to see the real time data and the game starts, and then it has to determine and identify what this type of image is, and this is very important task to identify the images. Now we are going to understand what is supervised learning and what is unsupervised learning. Now in supervised learning algorithm from labeled data training. Here data are labeled in labeled data. To understand this algorithm, we use labeled data in this algorithm, where each image is associated with the known category. This approach is common in image classification tasks. When there are known categories and data is correctly labeled, we use supervised learning. And in unsupervised learning, we this algorithm work with unlabeled data. Like data is not unlabeled, is not correctly assigned or not correctly classified. They aim to discover patterns and structure in data without explicit category labels. This approach can be used for image clustering and anomaly detection. Now, this unsupervised learning we use when there are anomalies or clusters of an image across like a dots, clusters of dots in small patterns. And in this type of images, we use unsupervised learning, and it is very helpful to identify the such patterns. Now, feature extraction and selection. Now, what is extraction? Feature extraction involves extracting meaningful information from images such as color histograms, edge detection, or texture analysis. And selection. Feature selection aims to identify the most relevant feature that contributes significantly to classify accuracy. It reduces the dimensionality of the data and improves model performance. Now, common algorithm for this image classification. Support vector machine SVMs, neural networks, and decision trees. These type of algorithms are commonly used in the image classification. SVMs are most powerful classifiers that are optimal hyperplanes to separate data points into different categories. They are effective for both linear and nonlinear classification problems. Neural networks are inspired by human brain itself. The name suggests a neural network. They consist of interconnected nodes organized in layers. Deep learning and subfield of the neural network has revolutionized image classification. Decision trees are trees in hierarchical structure to classify images. They split data based on feature and make decisions by traversing branches. They are interpreted and relatively easy to understand. Evolution matrices and performance measures. It has 80% accuracy, 95% precision, and 97% recall. After challenges and limitations we have faced. Conclusions where part of an object are hidden, making image classification more challenging. Illumination, changing light conditions can affect image features, leading to inaccuracy classification. Scale validation. Objects of different size can be difficult to classify consistently. Background noise can be also a problem. Distracting element in the background can hinder accurate classification. Now, real world application and case studies on this one. Now, in medical diagnosis, like diseases and accurate diagnosis. Now, for this, we can take example of cancer. Cancer cells and human cells are normal cells are completely different. They are like they have some color contrast or some different colors. Like normal cells are light in color, whereas the cancer cells are dark in color. By this measures, it it can take there's a number of it can count the number of cancerous cells and detect the cell and mm, define the problem statement and tell give the result. In same way in security system as well. Image classification is used in security system to identify suspicious object or individual, enhancing safety and security. Future trends and advancement in image classification, deep learning, explainable AI, and edge computation. Thank you. Have a great day.